So we've looked at the theory behind Newton's second law. Now we're going to look at and practice the equation and look at one key definition too. So we've said force, mass and acceleration are linked, and this is how. So you can calculate the resultant force of an object if you know the mass of the object and the acceleration that that force is producing. So again, we've got one of our formula triangles which will just help you manipulate this equation, where you've got F at the top, which relates to the force, the m relates to the mass, and the a relates to the acceleration produced by that particular force on an object of that particular mass. So we're going to try an example. So we've got a question here that says, a motorbike has a mass of 250 kilos. What is the force required to give it an acceleration of 5 meters per second squared? So just a quick glance at our equation. We want to calculate force, so I'm going to do mass times acceleration. So our force equals m times a, which equals 250 kilograms, times by 5 meters per second squared, which gives us a required resultant force of 1,250 newtons. So if you have a resultant force of that magnitude on an object of that mass, it will accelerate at a rate of 5 meters per second every second. One of the key definitions in this topic is that of inertial mass. The more massive an object is, the more force is required to change its velocity. That's what Newton's second law has been discussing. But we can actually refer to the mass of an object that's found by dividing the force that's acting on the object by the acceleration that force produces as the inertial mass. So if we know the force we're exerting on something, and we measure the rate of acceleration due to that force, we can calculate the inertial mass of the object. So that is the mass that's related to force and acceleration. So we're going to try an example just like we did before. So we have a question here that says a force of 200 newtons acts on a car and produces an acceleration of 0.25 meters per second squared. What is the inertial mass of the car? So if we look at our formula triangle again, remember how these work. We need to cover the variable that we are wanting to work out, in this case the mass, and we can see that we need to do force divided by acceleration. So we'll give that a go. So mass equals force divided by acceleration. That means we've got 200 newtons divided by 0.25 meters per second squared, and that gives us a total mass of 800 kilograms if you put that into your calculator. So the inertial mass of that car is 800 kilograms.